Hello, this is the first video for Unit 16, which is all about polygons. So, starting Unit 16, we're going to go over a lot of vocabulary today, talk about a few different things, but we'll start with polygons. So, all the things that we're going to talk about today are polygons. We've dealt with triangles. Triangles are a type of polygon. Polygon just means many-sided object. Okay, so square is a polygon, pentagon's a polygon. We'll get into more of that in a minute. Regular polygon is a polygon with equal sides and equal angles. So an equilateral triangle is a regular polygon. So is a square. And we'll get into some other. Convex and concave. Now convex is the type of polygons that we've talked about and that we work with. They look something like that, or a triangle, or a square, all right? There's a long definition that says if you can connect any two non-consecutive vertices and it goes through the interior, then it's a convex polygon, which means basically if I can just connect any of these dots, it goes through the inside. That's what makes it a convex polygon. A concave polygon is a polygon that caves in, like something like that. We don't deal with those very much, just because they're just not found very often in a lot of the upper level math that you're going to do. So concave, we're probably not going to see a lot. We're going to work with all convex in this class. All right. Triangle, 3 sides. Quadrilateral, 4 sides. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8. Nonagon has 9. Decagon has 10. Undecagon has 11. And a dodecagon has 12 sides. An n-gon is a general term. An n-gon has n sides. So we don't have to come up with a name for something like a 97-sided object. So anything after 12, we just call it an n-gon, or we put the number. So a 13-gon has 13 sides. A 19-gon, and that's how we name it, just 19-gon, would have 19 sides. So a 97-sided object would be a 97-gon. Okay. All right, scalene triangle, no sides equal. So this is review. We've seen it before. Isosceles triangle, 2 sides equal or congruent, that and that, which in turn means we have 2 angles congruent. Those are called the base angles. Equilateral triangle, 3 sides equal or congruent. So 1, 2, 3, which means we have 3 angles equal. So an equilateral triangle is a regular polygon from above, and a right triangle just has 1 right angle. We don't know about the sides. We just know that there is a right angle. All right? So those are the types of triangles. Again, that's review. All right, quadrilaterals. This is where, the majority of the new information is today. And there's a lot of information here when we talk about quadrilaterals and their characteristics. So we're just going to go through these and hopefully fully understand when we're done. So a parallelogram in general it's a quadrilateral with 2 sets of parallel sides. Okay, and that's the definition. Now, there's lots of other things going on there, but that's the main thing. That's what makes it a parallelogram. So to mark that, I would say this side would be parallel to that side, and we mark parallel lines with little arrows. And then this side would be parallel to this side. Now, there's other things going on here as well. In any parallelogram, opposite sides are congruent. So the top and the bottom would be equal, and the left side and the right side would be equal to one another. Okay. Another thing about any parallelogram is opposite angles are congruent. So that angle is congruent to that angle up there, and this top left and this bottom right would be equal. So I put 2 tick marks on those. So opposite angles are congruent. Now, another thing about it is, let me just number these angles. Let's say that's number 1, that's number 2, 3, and 4. So there's a lot going on in that picture. Another thing about them is consecutive angles, which are the ones next to each other. Consecutive angles are supplementary, which means they add up to be 180. So angle 1 plus angle 2 would equal 180. Angle 2 plus angle 3 would equal 180. And we could go on. 3 and 4 add up to be 180, and 4 and 1. So if they're next to each other, they add up to be 180. And it all has to do with these parallel lines and transversals, which we learned a long time ago. So if I talk about this top and bottom line being parallel and this being a transversal, 1 and 2 would be consecutive interior angles, which we said are congruent. So that's a parallelogram. And that's a big deal because a rhombus, a rectangle, and a square all fall under the idea of they are all parallelograms. So a rhombus, the definition is it is a parallelogram with 4 equal sides. So this, and this would be congruent to each other. Now it follows all the rules because since it is a parallelogram, then it follows all the rules of a parallelogram. So all these are true. I'm not going to rewrite them, but opposite angles are congruent. Opposite sides are parallel. All right? Opposite sides are congruent. They actually are all 4 equal. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Angle 3 and angle 4 are supplementary. And angle 4 and angle 1 are supplementary. 1 and 3 are equal. 2 and 4 are equal. So all of these things hold. The only difference that makes it a rhombus is that the 4 sides are equal. Okay? Now, every rhombus is a parallelogram, but not every parallelogram is a rhombus. So we'll get some true-false questions testing on that. Another type of parallelogram is a rectangle. So a rectangle is a parallelogram with 4 right angles. All right, so that, and that. Now, that follows the rule from above. So again, same rules apply for all of these are down here. Opposite angles are congruent. They're all 90. Consecutive angles are supplementary. 90 and 90 is 180. Opposite sides are parallel, just like they are here. Opposite sides are congruent. So this is equal to this, and this is equal to this. So a parallel, or a rectangle rather, is just a parallelogram with 90-degree angles, and that's what the definition is. Again, it follows all the characteristics of a parallelogram. So every rectangle is a parallelogram, but again, not every parallelogram is a rectangle. All right, square covers it all. All right, a square is a parallelogram with 4 equal sides and 4 90-degree angles. Now, a square is a rhombus because it's a parallelogram with 4 equal sides. So a square is a type of a rhombus, and it's a type of parallelogram. And a square is also a type of rectangle because it's a parallelogram with right angles. So basically, everything from this goes into here, everything from this goes into here, and everything from this goes into here. So a square covers all of it. So every square is a parallelogram, every square is a rhombus, every square is a rectangle, but you can't go backwards. You can't say every rectangle is a square. So in this picture, all 4 sides are equal. All of these are 90-degree angles. Opposite sides are parallel, opposite sides are congruent, opposite angles are equal, consecutive angles are supplementary, so it follows all the rules from above. All right, trapezoid. It's a quadrilateral with 1 set of parallel sides. All right, so the top and the bottom of this one are parallel. Sometimes you see them drawn sideways and then the left and right, but in this case, the top and the bottom. All right, now, a trapezoid doesn't have a lot going for it. All right, the one thing it does is some angle ideas, so let's label these angles 1, 2, 3, and 4. If it's just a plain old trapezoid, we can say that angle 1 plus angle 2 is equal to 180. So these angles are supplements. And again, it goes with this idea, if I extended these sides like that, I would have the parallel lines with the transversal that we talked about a couple months ago, and these two would be consecutive interior. Angle 3 and angle 4 also add up to equal 180. So angle 1 plus angle 2 equals 180, and angle 3 plus angle 4 equals 180. Okay? So that's all true. Now, we can't relate 2 and 3 or 1 and 4. All we can do is just these two go together, and those two go together. Now, if it's an isosceles trapezoid, all right, just like an isosceles triangle, it has two sides that are equal. It's those. It's a trapezoid, so it's got these parallel. All right, so the top and the bottom are parallel. The left and the right are congruent. Now, again, the only thing really going for it is those segments are equal, and we've got some rules with some angles. So angle 1 plus angle 2 is still equal to 180. And angle 3 plus angle 4 is still equal to 180 as well. Now, the only difference between an isosceles trapezoid and a trapezoid, an isosceles trapezoid has these base angles. So these are, the 1 and 4 are called the lower base angles. So angle 1 would be congruent to angle 4. And 3 and 4 would be the upper base angles, so angle 3 would equal angle 2, or angle 2 equals angle 3. Okay? And then 1 and 2 add up to be 180. So if I gave you one of these angles, you should be able to find the other three. And the last quadrilateral we're going to talk about is a kite, which just looks like a kite that you maybe flew when you were a kid. And a kite has two sets of consecutive sides that are congruent. And so this side and this side are equal, and this side and this side are equal, just like it looks like they are. The only thing else in a kite that maybe you'd ever use was this angle, and this angle would be congruent. Now these other two, you can definitely say this angle is bigger than this one, so just one set of congruent angles in a kite. So those are all the quadrilaterals, okay? We're going to add to that next time when we talk about the diagonals of those, and we're going to put some other segments in there and come up with some more rules. But a lot of theorems here, things that you need to know, you need to be able to recognize so that we can work further into this unit later on. So these are the basics. Everything is going to build off of these. So we're going to have some practice that you can do. Good luck on that, and let me know if you have any questions.